Welcome to episode 1 of the PySpark Masterclass on ByteSized data. I'm your host, Byte. Today, we're diving straight into the engine that powers the modern big data universe, Apache Spark. Look at the diagram on the right. Whether you are querying a massive 10 terabyte file, running complex SQL queries, streaming real-time telemetry, or training machine learning models, Spark provides a unified, lightning-fast computing engine. Instead of struggling with a single computer, Spark takes your massive workloads and distributes them seamlessly across a cluster. Let's pop the hood and see how it works. To understand why Spark dominates the industry, we have to look at what came before it, Hadoop MapReduce. Look at the top half of our diagram. In Hadoop, every single step in your data pipeline had to physically write intermediate data to a spinning hard drive and read it back over the network. It worked, but physical disk I/O was painfully slow. Now, look at the bottom half. Apache Spark revolutionized data engineering by processing everything directly inside high-speed cluster RAM. By eliminating the need to write intermediate steps to disk, Spark runs workloads up to 100 times faster than Hadoop. Now, let's understand how a Spark cluster actually executes your code. Look at the architecture diagram on slide 3. On the left, we have the driver program. This is where your Python script runs. The driver is the brain. It parses your PySpark code, builds an optimized execution blueprint called a DAG, and asks the cluster manager for resources. On the right side are the executors. These are the worker nodes in your cluster. Each executor holds a chunk of RAM and CPU cores, running multiple tasks simultaneously in parallel. The driver commands, and the executors do the heavy lifting. Let's look at some real code. On the left side in our code editor, the very first thing you create in any PySpark application is a SparkSession using the builder pattern. The SparkSession is your direct gateway to the cluster. Next, we call spark.read.csv to load our dataset into a DataFrame. Now look at the right side of the screen. To your Python code, a DataFrame feels just like a standard pandas table. But behind the scenes, Spark has automatically sliced that 100 gigabyte file into parallel partitions, distributing partition 1 to node A, partition 2 to node B, and partition 3 to node C without you writing a single line of networking code. And that is your first look inside the Spark engine. Here is a secret to think about. When we ran that spark.read.csv line in our code, Spark didn't actually read the file from disk yet. Why? Because of Spark's ultimate secret weapon, lazy evaluation. Make sure you smash that subscribe button right now, because in episode 2 next week, we are diving deep into transformations versus actions, and how Spark's directed acyclic graph rewrites your code to run at maximum speed. Beep boop, see you in episode 2.